Central tendency, the mean and the median. The mean of a set of data values is a simple arithmetic average, and the mode is the most common value. The median, on the other hand, is the middle value, and there is a reason to keep track of it as well. First of all, sometimes you have a measurement scale where you can calculate a mean, but it's not really meaningful. There is a difference, for example, between calculating the average time in minutes it takes you to drive home from work and calculating the average response to a 5-answer scale like this. Please rate on a scale of 1 to 5 whether you strongly dislike 1 or strongly like 5 chocolate. There is a problem with calculating an average that measures things that way, where 1 is strongly dislike, 2 is dislike, 3 is have no feeling, 4 is like, and 5 is strongly like. The problem here is that this isn't a scale with equal unit distance. It's what's called an ordinal scale. It has order or rank. In other words, there is a clear sequence that makes sense here, unlike what we have with the numbers on sports jerseys, which are effectively just names. However, on a scale of 1 to 5, strongly dislike, dislike, no feeling, like, and strongly like, we don't have equal unit distance between our answers. We can't say that the amount of difference in liking between answering 4 and answering 5 is exactly the same amount of increase as the amount of difference between answering 2 and 3, for example. This is unlike measuring time to get home in minutes, where each minute is exactly as long as every other minute, because the scale has equal unit distance. So you can average the numbers on that 1 to 5 scale of strongly dislike to strongly like, but it's not exactly a proper arithmetic mean. You could do something else as well, which is ask, what is the median response? Let's say you got 15 answers to that question, and they were 1, 2, 2, 3, 3, 3, 3, 4, 4, 4, 5, 5, 5, 5, and 5. The median is the value you get once the numbers are put in order that is exactly in the middle, with an equal number of values above and below it. In this case, the number 4 is the median because it has 7 values above it, and the same number, 7, values below it. If, on the other hand, you had an even number of numbers, you would take the middle 2 numbers and average them, and that would be your median. If you had 16 responses, and they were all of those, the middle 2 numbers are 3 and 4, so the median is 3.5, the average of those 2 middle numbers. So, is there any other reason to get the median of a set of values? Sometimes, even when you measure things on a real numerical scale with equal unit distance, you might still prefer the median to the mean. The reason for this is that numerical values don't always balance out to a nice average that tells you what is typical for a group. For example, let's say you're looking at a company's income, or firm size as measured by headcount, the number of employees. Or similarly, if you're looking at household income. All of those things tend to follow a somewhat unbalanced pattern. Looking at this chart of income distribution from the Census Bureau, we see a lopsided or skewed curve. Most of the values that people experience are on the lower end, but there are some very extreme values out on the right. In fact, some of the household income values are so extreme that they simply don't fit on this chart. That's why getting an average is not really very meaningful here. We expect measures of central tendency to reflect what is typical or normal. But if you average something like income with an arithmetic mean, you don't get anything typical at all. For example, in a 1-year period between October 2017 and October 2018, Jeff Bezos of Amazon made $78.5 billion. Adding that kind of money to the average we're all a part of makes it seem like most of us have money that we don't have. For perspective, the mean household income in the U.S. in 2018 was $106,045. The median household income, representing the income of a household with an equal number of incomes above and below it, was $78,646. For most households, $78,646 felt a lot more like what they experienced than $106,045. The reason median is more useful in situations like these is that it isn't sensitive to outliers or extreme values. No matter how much the richest person makes, the median doesn't change. The mean does, though. Extremely high values make the mean higher, creating a value that is not really representative of what most people experience. The mean isn't resistant to outliers like the median is. For example, if you have these 5 hourly incomes, 15, 15, 25, 35, and 50, the median is 25 and the mean is 28. Not terribly different. On the other hand, if the incomes are 15, 15, 25, 35, and 8,961,187, where that 8.9 million was Jeff Bezos' hourly earnings in 2018, the average is now 1,792,000 and the rest. But the median doesn't move. It's still 25. It doesn't care at all how high or low the extreme values are. So, knowing that the mean in that group is $1.792 million and the median is 25, which value do you think represents what most people in the group think is typical or normal? This is why pretty much universally, income is discussed in terms of the median. It's not just useful in describing data values that are only ordered like numbers in a 1 to 5 survey of preference. It's also useful in describing groups of data values that include extremely high or extremely low values that make using the mean impractical.